Hey everyone, welcome to today's session, and we're going to be talking about how to get started with Tanzu Community Edition, the freely available platform for learners and users who want to get going with Kubernetes. My name is Kenny Coleman, and I'm a senior manager under Tanzu Technical Marketing. I've been doing a lot of things with inside the Kubernetes realm for a few years now. I was on part of the Kubernetes release teams from 1.12 through 1.16. I was also been a part of a lot of the open source projects that have been inside of the walls at VMware. I also was a part of the teams for Tanzu Basic, Tanzu Standard, Tanzu Mission Control, and Tanzu Kubernetes Grid, as well as vSphere with Tanzu. And now I'm very pleased to be able to talk to you about Tanzu Community Edition, about how we're wrapping in a lot of these components to provide a free platform for you to get started and how you can utilize all these different things inside of Kubernetes to create a platform that you need and how you want to deploy your applications and how you can really get started. So let's go ahead and we'll dive into it. So the big note here is to understand that this is free. Yes, Tanzu Community Edition is absolutely free. You can go to the website at tanzucommunityedition.io. You can download and get started right away. There's a getting started guide. There's documentation on how to do it with your favorite platform, whether it's on-premise or in the cloud. The one thing to know about Tanzu Community Edition is that it does come with just community support. So keep that in mind when you are starting this. Now, everything inside of Tanzu Community Edition is the same open source software that's used in all of our commercial editions. It's freely available, absolutely no cost at all, and no limitations. You can also install and configure it in minutes, meaning that it's as simple as doing a brew or a chocolatey install into your own laptop. And from there, you're off and running with the Tanzu CLI. And we'll show that in a demo here at the very end. And again, you can configure this to run either locally on your own workstation, or you can run it in your favorite cloud, such as maybe AWS, Azure, or of course, vSphere. So let's dive into what can we do with Tanzu Community Edition. Well, we're going to talk about these different pillars. Now, each of these pillars, we're going to dive into them a little bit deeper. So we're going to talk about the architecture. How do we want to utilize Tanzu Community Edition? We're going to talk about how we integrate into our existing infrastructure, not just from a compute side of actually getting Kubernetes up and running, but how do we do it for persistent volumes? How do we do it for container networking? And how do we do it for even DNS routing? We also want to look at how do we consistently deploy our applications across any cloud. Just because you have Tanzu Community Edition doesn't mean you're limited to one cloud. Instead, you can provision it to multiple clouds, and you can have your applications spread across multiple clouds as well. And you can do that all within inside of here. Of course, security is always top of mind. We have to be conscious of what we are provisioning in our ecosystem and our environment to make sure that we're being compliant and knowing that what we're providing you is the most secure platform that we can to be able to run your applications on Kubernetes. And lastly, we all need to make sure that we can manage and observe our entire infrastructure. And we can do this through a few different integrations of being able to collect logs from everywhere, as well as being able to visualize everything in a time series database. So let's dive into it. The first thing to do is look at the different types of architecture. So Tanzu Community Edition has really two different types of architecture. The first is the managed cluster architecture. If you've been around the Kubernetes ecosystem for a little bit, you might have heard about this project called Cluster API. Well, Cluster API essentially is a way for us to create first what's called a management cluster. This management cluster is just a Kubernetes cluster that has been outfitted and deployed with the Cluster API CRDs, or custom resource definitions. Now, what that allows us to do is, as an operator, what I can do is I can provide a declarative model to it, meaning that I'm going to provide a configuration file that says I want a Kubernetes cluster that has one control plane node, 5 worker nodes, and use an Ubuntu image with this particular Kubernetes installation. Go. And from there, Cluster API is going to be responsible for going and provisioning that cluster and building the cluster and making sure it integrates into that particular cloud provider platform. And again, this one management cluster can span multiple workload clusters. Now, the other cool thing about this is that Cluster API also provides complete lifecycle management. That's everything from creating, scaling, and deleting your clusters. Again, this is also for having that desired state-like configuration. Now, on the other side of this, we also have a newer type of architecture called standalone clusters. And this is a faster way to get workload clusters up and running. These can run on any cloud. They can run on your own desktop. but there's no management cluster that's going to be needed. It's useful for things like doing short-lived demos, like maybe what we're going to do today. If you want to do any kind of immediate CI/CD testing locally, you can get that spun up, or you can just do it for any sort of development purposes. Really, it's up to you to decide how heavy do you want it to use it? Do you need all those lifecycle management capabilities? Or I guess you could say for long running clusters, or do you just need something to spin up quickly and to just get started using Kubernetes? And again, this whole thing is for learners and users. So if you're just wanting to learn Kubernetes, you can learn it on a standalone side, and then you want to learn how to do it on a more production-like kind of scale, then you can go to the managed cluster route. So let's talk about how we integrate into your preferred infrastructure. So today, we utilize Cluster API as our declarative way of having to actually automate everything we want to do for Kubernetes cluster lifecycle management. Now, part of that process means that we build out the image, the Kubernetes image that you're going to get. And with inside of that Kubernetes image, you're going to have a few different things. First is you're going to have the CSI driver. CSI driver stands for the Container Storage Interface. And this is going to be responsible for creating persistent storage and attachments. So no matter which cloud we go to, so let's say we deploy to AWS, the CSI driver is going to be responsible for talking to, say, Elastic Block Services or EBS. If you were running on vSphere, it could be responsible for creating a VMDK inside of an existing data store. Again, this is all pre-done as a part of the setup process when you're creating your management cluster to say, how am I going to configure and how am I going to talk to my storage? And this is going to be responsible for, again, making sure that you have that persistent data that can then attach to those virtual machines that are running inside of, and then your pods that are running inside of your virtual machines. So it's doing all that stitching for you. Next is we also have the CNI driver. We include two CNI drivers by default. We have Antria and Calico. So Antria is deployed by Antria is deployed by default, and Calico is there still if you need it. But what this is responsible for is for your east and west networking going on between your pods. So just because a pod lives on one virtual machine and another pod lives on another virtual machine, well, CNI is going to be responsible for making sure that those two can communicate to one another. And this is done through things like VXLAN. And again, nothing that you have to configure. It's embedded and just works out of the box. So if you were to do this on your own, if you can go and you can check out how to build your own Kubernetes cluster, everything from creating your own services to then deploying your own daemon sets that have your CNI adapters to finally get everything communicating. Well, this just does it automatically for you. Now, more than just creating a pod and having them communicate, that doesn't mean from the outside I can communicate. So what we want to do is we want to provide native layer 4 load balancing primitives. And this is all done through the CPI or the cloud provider interface. And what this does is this knows how to communicate to any type of external load balancer service that you've configured. So if you're going to AWS, of course, Elastic Load Balancer will be provisioned. If you're using, say, vSphere and you have NSX ALB or formerly Avi that's been deployed, well, you can use that to then pull a virtual IP from Avi, and then now you have that north and southbound communication. That's how we can access our applications running inside of Kubernetes. Now, very often in times, you might have certain rare cases where a particular application needs to have its own private network, and there might be multiple pods that need to communicate on this private network as well. Well, that's why we can leverage multi-homed pods with another application called Multis. Now, Multis allows us to have multiple Ethernet adapters onto a single container. And with inside of that container, it's not going to interfere with anything that connects to the CNI. That allows that external communication to be able to go through all the other pods and all the other virtual machines that are running all those pods. Now, the other piece of this is DNS. DNS is typically a very manual process. So as mentioned before, we create that layer 4 load balancer service. We get an IP address. Well, if I want to access the application running inside there, I have to go to my DNS server and I've got to create an A-name record so I can then contact it. Well, external DNS actually makes this all automatic. What this will do is I can place an annotation on a particular service, and that annotation knows how to talk to my DNS service. And once it's created, it will go and automatically create an A-name or a C-name record inside of the DNS service so I can go ahead and talk to it. And this is, again, you can do this for layer 4. You can also do it for layer 7 ingress types of services as well. And again, this is all done declaratively through Kubernetes cluster lifecycle management, of being able to say, if I want to provide this type of configuration of having one control plane node, 10 worker nodes, running Photon OS with Kubernetes 1.22, well, I provide that to Cluster API, and then that knows how to talk to my infrastructure provider. It knows how to talk to AWS. It knows how to talk to vSphere and spin up virtual machines, whether they're EC2 images or just virtual machines running inside your cluster inside of vSphere. It knows how to do all that. So we are integrating into all of these pieces of infrastructure and making things a lot more streamlined for you as well. We also want to make sure we can consistently deploy our apps across any infrastructure. Now, as we're deploying our Kubernetes clusters with Cluster API, by default, they are upstream conformant, meaning that we are not taking a fork of anything running inside of Kubernetes. Instead, we are taking everything that is coming from the Kubernetes community and providing that as an image that you can then use to deploy. Now, you get this other package called Sonobuoy. So Sonobuoy is going to be responsible for making sure that you can run conformance tests against your existing clusters. So if anybody goes and tries to make a cluster not look like, or make it look like a snowflake, you can then get reports for it. And you can go ahead and remediate it at that time. Now, the other part of actually having that base OS is making sure that that base image that we supply is to make sure we ensure interoperability. I've talked about so far about 8 different things that you need for types of drivers on how we integrate. Now, take that and expand it even further with things like Containerd, etcd, so on and so forth. There's 30 or so odd different services that need to all make sure that they are interoperable between each other. To do that on your own, it might take a whole team to figure out, well, how do we make sure that we have interoperability between all these different drivers as well as the Kubernetes versions? Well, there's a lot of reading, there's a lot of documentation that's out there, but we do all that for you. We provide the images for you to make sure that you not only have a seamless experience on deploying your infrastructure, but it's also a seamless upgrade experience at the same exact time. Now, part of the Tanzu CLI is we've also include this new packaging format called Carvel. Now, Carvel allows us to actually deploy different types of applications running into Kubernetes. This is things that we need, such as Prometheus, Grafana, Harbor, Valero, Contour, Cert Manager. We'll talk about all those here soon, but Carvel is really the tooling that makes this all come together. This is going to take care of not only just simplified deployment, but as well as upgrade processes and procedures as well. Now, I mentioned Harbor already, and Harbor is going to provide you with an enterprise class container registry. And we're going to talk about it when we get more into the demo. But one of those things to kind of understand about Harbor is that it provides things such as critical vulnerability scanning, replication, it has tagging, it has all kinds. There's just so many features. It was one of the things that I originally had worked on, but you can go find a lot more information about it. And we'll, again, look at it in the demo and how we can push and pull images from it and how it does a lot more than just what you can get out of a public registry. We also want to enable our developers that are looking into sort of maybe doing things that are event-based type of applications. You want to do things that are done via kind of like Lambda. So we want to enable serverless types of applications, and that's all done through Knative serving. We also want to provide a high performance layer 7 ingress load balancer. And this is done with Contour. So Contour is going to be your ability to not burn up a lot of IPs. I'd mentioned earlier about being able to integrate natively with layer 4 load balancers. Every time you do that, you burn up an IP address. Well, with layer 7 ingress, instead you just use one IP address and then you route based on the application. Lastly, you want to have sort of some peace of mind. So you want to protect all of your, not only just your container configurations, but as well as your persistent data. And that's all done with Valero. So Valero comes as a part of this, and you can back up anything that's running inside your cluster to an S3 data store. And you can also restore back to that cluster or to any cluster. So this is a way that you can start practicing and getting used to disaster recovery scenarios and how to do automated backup and restores through different types of cron-like jobs. As I mentioned before, security is always top of mind. We want to make sure that we have secure end-to-end native cloud operations. Well, part of this in the first point is that we provide that base image. Well, not only is it just a base image that we provide, but it is signed by us. It's signed by VMware, and you can utilize that to then make sure that you are staying up to date and you have all the latest patches. And today we provide 3 different kinds of base images. We could provide Photon OS, Ubuntu, and if you're running inside of Amazon, and AWS, AMI. Now, as a default part of this is that there is encrypted communication that's happening between Kubernetes services. Again, this is just something that comes default out of the box and nothing that you have to set up. But if you want to have some sort of encrypted communications for your own apps that you deploy, well, we've also included the ability to deploy Cert Manager. Cert Manager is a way to automate certificate rotation for your apps, and maybe you want to use things like Let's Encrypt. Well, we're going to show you how to do that in the demo as well. I'd mentioned Harbor before, and Harbor has the ability to scan for critical vulnerabilities at the base layer, at the image layer. So you can get a report of what images have been pushed, and you can scan them on push. You can get an idea of what sort of vulnerabilities look like. You can get a report on them, and it's up to you to go and figure out, do you want to go and patch these? You can also set policies that says do not pull if it doesn't meet a certain requirement or level, whether it's low, medium, high, or severe, and you can make sure that people don't pull those. You have the ability as an administrator to make sure that you own the types of images that are being deployed into your environment. Or you can have somebody that just wants to spin up their own Harbor instance and just kind of have their ability to kind of see how they push and pull images as well. Now, we also want to make sure that we're authenticating if we need to move this into almost, like I said, a production-like experience. Well, we also include Pinniped. That is your integration into LDAP and OIDC services that you can use for authentication. And lastly, we also can enforce custom policies through Open Policy Agent's Gatekeeper. This is your ability to not have to just set policy one time on one cluster and go through and make all these changes, but instead you can do it programmatically. You can create a type of policy and then you can apply it to every single cluster, and it will go ahead and it will make it a lot more seamless and a lot more easier. We also need visibility into our cluster operations and as well as into our applications. So we provide some tooling for that as well. As part of the Tanzu CLI, you can easily deploy FluentBit. FluentBit will automatically, and with a small configuration, it will automatically ship all your logs from your Kubernetes cluster to any sort of log collector that you want. So whether you're using Elk or Kibana, Splunk, vSphere Login, or vRealize Log Insight, it can deploy and ship your logs anywhere. So that's everything from your Kubernetes services all the way down to your pods and the applications that are running inside those pods. And you can get those and you can make sure that you can set any kind of alerting that you need through there. We also supply Prometheus and Grafana. Prometheus is going to be responsible for tracking all of your metrics in a time series database. And of course, Grafana is one of the best tools out there to visualize Prometheus data. And it does that through a few different dashboards. Those dashboards that you can go get from grafana.com, and you can go and install your own way to look at Kubernetes, your own way to look at your way that you deploy Harbor. You can have a Harbor dashboard. You can have your own applications for your web servers, and you can have your own dashboard for that. It's completely customizable on how you want it to look. The other thing is that Prometheus also has a learning capability. So if you have any applications that you want to configure to alert to Prometheus, you can do that as well. So here is an overview of the entire platform. So we touched on every single one of these components as we started building this up. And now we have the ability to start looking at, this is how we package everything into one single CLI. And this is again, completely free, no charge. You can get started today, tanzucommunityedition.io. But let's go ahead, let's dive in with a demo. In this demonstration, we are going to deploy a Kubernetes cluster and get our first application that will be pulled from Harbor up and running behind an ingress controller, all while using Cert Manager to provide valid TLS certificates from Let's Encrypt, all using Tanzu Community Edition. Let's go. The first thing to do is create our management cluster. This will be responsible for the lifecycle management of any Kubernetes cluster that we create hereafter. Using the Tanzu CLI, we can spin up the Bootstrap user interface to make plugging in environment variables much easier. We have the option of choosing Docker, vSphere, AWS, and Azure as our infrastructure targets. Each one has its own unique set of requirements. For instance, with vSphere, we need to connect to our vCenter environment. And after selecting a data center and putting in a public SSH key, we can set our management cluster specifications, such as the size of the virtual machine, the name of the cluster, and if we want to use KubeVip or NSX Advanced Load Balancer to provision the resources needed to reach the Kubernetes API. There are more requirements, such as settings for the NSX Advanced Load Balancer, specifying the changes that might be needed to Kubernetes network CIDRs, and then specifying which base image we want. If we want to integrate with Pinniped for LDAP or OIDC authentication, that can be sent as well as also having the option to register this cluster with Tanzu Mission Control. In my environment, I have 2 management clusters up and running, one in vSphere and another in AWS. I can select which management cluster to interact with by using Tanzu Login. And after selecting the management cluster, I can run Tanzu Cluster List to see any Kubernetes clusters that have been deployed and are managed by this management cluster. My preferred architecture is to deploy a Kubernetes cluster that will be responsible for shared services. I have created this cluster called TCE AWS Services, where I have Harbor deployed, which is where we'll be pulling our images from later on. Now I'm going to create a cluster by giving it a name of TCE Demo 01, but also specifying a configuration file that was copied from the generated management cluster. This configuration file contains environment variables such as my AWS credentials, the region of where this will be deployed, the type of AWS AMI, the size of the virtual machine, any network configurations, and more. This entire process takes about 10 minutes to have a Kubernetes cluster up and ready to go. And I can verify the virtual machines were created in my EC2 dashboard. Once the cluster is ready, I can retrieve the kube config by using the Tanzu CLI and then set my context to point to the new cluster. A simple get pods from all namespaces shows me that I have a Kubernetes cluster up and ready to go for any type of application. At this point, Tanzu Community Edition has shown how easy lifecycle management of Kubernetes can be, but it goes much further. Tanzu Community Edition brings in the capability to deploy other necessary applications that are critical to the success of the overall Kubernetes deployment. Using the Tanzu CLI, we will add a new repository called the TCE repo, which is a collection of applications supported by the Tanzu Community Edition community. After the repo has finished reconciliation, we can list all of the objects available to us. And as you can see, we can easily deploy Harbor, Contour, Valero, Prometheus, Grafana, and many others. All right, let's see what it takes to create our first web app that will be running behind an ingress controller and also has trusted TLS certificates. To do this, we're going to deploy Contour as our Layer 7 ingress controller. We can choose which version of Contour we want to install by listing out the available versions that have been packaged up for us. For this demonstration, let's choose the latest available, which is 1.18.1. Installation is as simple as saying Tanzu install, the package name, and the version. After a few minutes, the application will be installed and reconciled. We can verify it installed correctly by doing a kubectl git service on the Project Contour namespace that shows us we have an AWS Elastic Load Balancer resource that has been provisioned for us. Next, we need something that can take care of TLS certificate rotation. Cert Manager can accomplish this. Let's follow the same instructions as before by specifying the package and the version in the Tanzu CLI and wait for the reconciliation. It's also worth noting that all of these packages within inside of the Tanzu CLI and Tanzu Community Edition are completely customizable. Variables can be overridden using the values.yaml file, and you can learn more about this in the documentation. Installing Cert Manager is only one step of the puzzle here. We still need to provide a certificate issuer. I'm going to install 2 of them for Let's Encrypt. The first is going to be set to the staging server, which is what you would use for testing all your scenarios because no rate limiting is involved. The next is going to be the production server, which will provide a trusted TLS certificate for the browser, and we will not be met with any error warnings when accessing the web app. All right, now it's time to deploy our application. I'm going to install a simple Nginx server, but I'm going to be pulling it from a Harbor instance that was running in my services cluster. Going into Harbor, we can see that the image exists in the Tanzu project folder, which is essentially a namespace. And when I dive further into the image, I can see the critical vulnerabilities that have been found, and I can click on each one of them to learn more. Harbor has lots of enterprise class features, such as replication, robot accounts, online garbage collection, tag retention policies, project quotas, and much more. The next thing to do is create a Kubernetes service that uses the selector to tie it back to our app. I'm not specifying a type of service here, such as load balancer or node port. I'm just specifying a generic service that we are going to use to stitch to the ingress service later on. But now let's go ahead and create our first ingress service. This is going to provide me a route based on the host name, and we'll go to the root directory, and we'll be using the service of TCE Nginx that we just created previously. All right, now let's access the web service. To do this, we need its IP address, but since this is running inside AWS, we can get the DNS name of the load balancer. Let's head over to our DNS server and create a new record. Most platforms will require an A name record since DNS is pointing to an IP, but since we're running on AWS and going from DNS to DNS, we will create a C name record. After the record has been created, we can wait a few moments to let DNS do its thing, and now accessing the web page shows that it's not secure, which is what we expect. But let's go ahead and change this up and get a trusted TLS certificate. We can either edit the ingress service that's running to add the cert manager annotations, or we can just go ahead and delete it and re-add it. I opted to delete, and now when we look at the new ingress route, it's very similar to the last one. We only added annotations for talking to cert manager and which cert issuer it should point to. We have also added the TLS section for creating a new secret. After applying this new ingress service, we can do a kubectl get service, and we can see there is a CME-ACME-HTTP resolver, which is running, which is creating the certificates by talking to Let's Encrypt and issuing them to our applications. But after a few moments, that pod will disappear. Now, going back into the web interface, we can point to our browser to the HTTPS side of things, and we get a trusted lock symbol in the browser. And we can further evaluate that this is coming from Let's Encrypt. There was a lot going on with that demo. We were able to deploy our first Kubernetes cluster, doing it through a declarative configuration. We installed Contour as well as Cert Manager, utilizing the Tanzu CLI, and we were able to deploy our first web app and be able to have that be seen as a not secure and then moving it to production as a secure type of application. So if you want to learn more, make sure you go and join the community. We have a lot of different resources available for you. We have a hosted sandbox that you can go and just get started today. And you can do that at the Tanzu Development Center. You can just go ahead and just Google Tanzu Developer Center and be able to take you there. And there's all kinds of great resources on videos, samples, and even live environments. If you're just getting started with Kubernetes and you need to learn some of the basics again, what's a pod? What's a daemon set? How does the control plane work? Go and check out Kube Academy, a lot of educational courses that are done through video types of tutorials. If you want to get even more involved, please come join the conversation. And you go to the Kubernetes Slack, and there's a channel for Tanzu Community Edition. You can also join our Google group, where you can get information on how to join on our open office hours and our community meetings, as well as get any other type of support. Again, all done through the open source community, but most of the support, make sure you go to the Slack channel to get any type of information you need. And from there, you can engage directly with the development team because that's where they're all hanging out. So once again, go and check it out, tanzucommunityedition.io. And if you want to even get more hands-on with a live environment right through your web interface, go to tanzu.vmware.com/developer. I want to say thank you all once again. Enjoy the rest of your sessions.